Hello, this is the luckiest maths teacher in the world. Today we're looking at terminating and recurring decimals. So we've already learned that if we have a fraction, we can write it as a decimal that has the same values. You know, a half is 0.5, 3/5 is 0.6, and so on. So it turns out that any fraction, as long as it has a whole number for numerator and denominator, it can be written as either a terminating decimal or a recurring decimal. So let's look at exactly what they are. So the word terminating means ending. You know, if you terminate something, you end it. So these are fractions that when you write them as a decimal, the numbers after the decimal point eventually stop. So what do I mean by that? So for example, if I have 2/5 and I convert that into a decimal, remember I want to make the denominator a power of 10. I want to make it 10, so I times top and bottom by 2, I get 4/10. 2/5 is the same as 4/10, and I can write that easily as a decimal. I just put a 4 in the tenths column. So 2/5 equals 0.4. There is only one number after the decimal point. It stops after the first digit, the 4. If I write 3/4 as a decimal, it ends up becoming 0.75. So this time there are two numbers after the decimal point, but again, it stops eventually. Another example, let's say I have 9/16. This is actually 0.5625. So there are a few numbers after the decimal point, but they stop after the fourth number. It doesn't go on forever. If it goes on forever and has a pattern, then it's a recurring decimal. So not only do recurring decimals go on forever, the numbers after the decimal point don't stop, there must be a pattern. So I'll explain what that means. So if I want to write the number 1/3 as a decimal, I can't write it as a terminating decimal. It actually equals 0.33333. It goes on forever, doesn't stop. But there's also a pattern. Each number after the decimal point is a 3. So it's much easier to write this like this, 0.3. We put a dot above the 3 to indicate that the 3's go on forever. And this is the exact way to write it if we write it with a dot. So this doesn't stop. We just write it as 0.3 with a dot above for convenience, but it goes on forever and there's a pattern. So let's look at something like 4/11. Well, that actually equals 0.3636 and so on. The 3's and the 6's go on forever. There's a pattern to it. The first, third, fifth, seventh, etc. numbers after the decimal point are all 3. The second, fourth, sixth, eighth, etc. numbers after the decimal point are all 6. So this one is recurring and it has a pattern. So 4/11, we can write it like this, 0.36. Now because the 3 and the 6 both go on forever, we can put a dot above each of them. You can also see it written like this, where you just put a dash above the 3 and the 6. Okay, another example of a decimal that goes on forever would be 5/12. Now, if you put that on your calculator, that equals 0.41666, and only the 6's go on forever. So the way we write that in exact form, we write 0.416, we only put the dot above the 6, because only the 6 goes on forever. The 4 and the 1 don't keep going. So they're examples of recurring decimals because they go on forever. So now we're going to look at how to actually convert fractions to recurring decimals. So in this example, I'm going to write 4/9 as a decimal. Now, it turns out that this will be a recurring decimal. Now, I told you in previous lesson, what we try and do when we want to convert fraction to decimal is we want to multiply the top and bottom number by something, so the bottom number, the denominator, either becomes a 10, 100, 1,000, or 10,000, a power of 10. We can't do that with 9. 9 doesn't go into 10, it doesn't go into 100, it doesn't go into 1,000 or 10,000. That's why this has a recurring decimal. So we need another way to do this. So what we can do is recognize that this fraction line actually means divide. 4/9 is the same as 4 divide 9. In other words, the answer to this is how many times 9 goes into 4. We're going to use the short division algorithm to write this as a decimal. So, how many times does 9 go into 4? Well, it doesn't go into 4 any time, so put a 0 there. So what we do is we recognise that 4 can be written as 4.0 or 4.00, whatever. So we move the 4 along here because 9 doesn't go into 4. Then we say, how many times does 9 go into this number here, 40? It goes 4 with a remainder of 4. How many times does 9 go into 40? It goes 4, remainder 4. So we actually need another 0. We can just add as many zeros as we like because 4.00000 is the same as 4. So 9, how many times does it go into 40? Again, 4, remainder 4. And what you can probably see now is there is a pattern. Each number after the decimal is 4. We could just keep going forever and ever and ever. But instead, we'll stop once we recognize the pattern. So when you're doing this short division algorithm, make sure that the decimal point in your answer goes right on top of the decimal point in the question. So we've just figured out from the short division algorithm that 4 over 9 is the same as 0.44444. It goes on forever. So we can just write it like this. Okay? Now I'll do the same with another one. So let's say I want to do, let's try 7 over 6. I want to write that as a decimal. So we're going to use the same trick. We're going to use the short division algorithm. So make sure you get the numbers the right way around. 7 divided 6 means that we're saying how many times does 6 go into 7. So I have to write it like this. 6 goes into 7. Okay, so how many times does 6 go into 7? Well, it goes in once, but there's a remainder of 1. 6 times 1 is 6 plus 1 more. So what I need to do is I need to write this as 7, and I can put as many zeros as I need, and then I carry the 1 over here. So how many times does 6 go into 10? Well, 6 goes into 10 once, remainder 4. So now I'm looking here. How many times does 6 go into 40? It goes in 6, remainder 4. How many times does 6 go into 40? It goes in 6, and I need to have a remainder 4. So for that, I need to add another 0. How many times does 6 go into 40? It goes in 6, and then there'd be a remainder 4. But you can probably see by now that the 6s are just going to keep going forever and ever and ever. So I can stop once I see the pattern. Again, decimal point has to be above decimal point. So what I figured out is that 7 over 6 is 1.1, and then the 6s, only the 6s go on forever. So we say that 7 over 6 equals 1.16 recurring. So now we're going to look at the other way where I give you a decimal, a recurring decimal, and you've got to write it as a fraction. That actually tends to be much harder, so make sure you're paying attention. Okay, so this part of the video is only for yellow students. If you're a green student, you can stop watching the video now. This is quite complicated. All right, let's get into it. So I want to write 0.7 recurring as a fraction. So this is what I do. I'm going to let x equal the decimal. So it equals 0.777, and it goes on forever. I'm just writing out all the 7s so the example will be easier to follow. So if that's x, and we want to write that as a fraction, I can times each side by 10. So if I times x by 10, I get 10x. Now 0.7 recurring times 10, remember that just timesing by 10 just moves the decimal point 1 spot to the right. So 10 times x will be 7.7 recurring like this. Okay? So now what I do is I take the 10x, the second part, and I minus the top part. The reason is that all of these 7s will cancel out. I can actually get rid of the recurring part of the decimal, and that's what makes this question hard. It's hard to work with. So 10x is 7.777 recurring. X is 0.7 recurring. So if I minus this top number from this bottom number, as I said, the 7s just cancel out. 7 minus 7 is 0. 7 minus 7 is 0. And you keep doing that, you just have a whole bunch of zeros. So 10x minus x, which is the same as 9x, equals 7.7 recurring minus 0.7 recurring. It just equals 7. Okay? So 9x equals 7. If I want to find what x is, this is just an equation. I have 9 times x equals 7. 9 times an unknown number equals 7. So the way I solve this equation is I divide each side by 9. So x is 7 over 9. So 0.7 recurring, I've changed to 7 over 9. All right, I'm going to do one more example. So please copy this down if you need it. Okay, so in this example, I'm going to write 0.74 recurring as a fraction. So same trick as last time. I'm going to let x equal 0.7474 goes on forever. Okay, now I want to times x by a number that has the exact same numbers after the decimal point. In the last example, there was only one number after the decimal point, which was 7 in the previous example. So I times each side by 10, so I could just move the decimal point one spot. This time, I want to move the decimal point 2 spots, so that the number after the decimal point is still 747474. So because I want to move the decimal point 2 spots, I need to times each side by 100. So I get 100x equals, so now after I've moved the decimal point 2 spots to the right, I get this. So remember, timesing by 100 just moves the decimal point 2 spots. So 100 times x is 74.74 recurring. So what I've got now is the same number after the decimal point in both of these numbers. And that's what I want, because that means I can subtract them. And that means I will get rid of all the numbers after the decimal point. So what I'm going to do is I'm going to take my 100x and minus x. So I've got 74.747474 going on forever, and I'm going to subtract 0.7474 and so on. Okay? So if I subtract them, I get 4 minus 4 is 0, 7 minus 7 is 0, 4 minus 4 is 0. The zeros keep coming, and then I get 74 minus 0 is just 74, right? So I don't need to write all these zeros after the decimal point. I can just get rid of them. So if I subtract this number here from this number here, I get 74. So I have 100x minus x, which is 99x, equals 74. Exactly what I did in the last time. The last example, I can just divide each side by 99. That's how I get x by and solve the equation. So x will just be 74 over 99, and I'm done. All right, this has been the luckiest maths teacher in the world. Hope you have a great day.